In this page, which is 13 and 14, we are going to extend our use of Venn diagrams to be, instead of just talking about sets, we're going to talk about probability. And the way you do that is pretty easy. Up until now, we've been concerned with just counting how many elements in each set and just, figuring out what the union, the intersection is. Once you do that, you have pretty much calculated the probability as long as each element that's in the sets or outside the sets has an equal probability. So, like if you say, hey, I'm going to put, three people outside, and I'm going to put two people here, I'm going to put one person here, I'm going to put four people here. Now, if you say, what's the probability that the person is in both set A and B? Now, you've already figured out the intersection, that's like one person there. And then if you just like say, hey, one person in the middle, how many people total? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a 1/10 chance that the person is in both sets A and B. So it works kind of like that, right? You just like count the number of elements that are in the condition that you want, and you divide it by all the elements that you're thinking about, okay? And these laws here are just, basically saying, hey, uh, if the probability of your event is 1/10, for example, like what's the probability of your event not happening? Well, it would be just 1 minus 1/10. That makes sense, right? So like if it's a 1/10 chance that this person is selected, it's a 9/10 chance that anyone else is selected. So that's what the complementary events law is saying. For combined events, what they're saying is, hey, if you want to figure out what the probability is of either A or B happening, what you do is you count everybody in A, that's 3/10, and then you count everybody in B, which would be 5/10, and then you subtract out the people that are counted twice, which is 1/10. And then that would give you 7/10, which is exactly how many there are in A and B. Okay? So it's just saying, hey, add everybody up in A, add everybody up in B, subtract out who's in both, so not to double count them, and everything's divided by 10 because that's the size of your universe. Right? So that's pretty much all we're going to use here. Let's look at number 1. A random experiment is roll an unbiased six-faced dice. Let A be the event, roll a square number. So A is going to be roll a square number. Okay. And B is going to be roll a factor of 6. Factor of 6. Okay. So list the elements of A. A would be square numbers, so that would be 1 or 4. And it's a six-sided dice, so that's all you can have. List the elements of set B. Set B is factor of 6. So a factor of 6 would be 1, 2, 3, or 6. Okay, now show sets A and B on a Venn diagram. Okay, so let's see. A would be 1 and 4. B would be 1, 2, 3, 6. Now we can see 1's in both, so we want to put 1 in the middle. Okay, so now we've done that. Write down the probability of A. Well, the probability of A is going to be for the number of elements in A, which would be 4 and 1. That's 2 elements in A. And then how many total? It would be 6. By the way, what's outside the sets? Well, we have 1, 2, 3, 4, 6 inside. What's missing? Just 5. So 5 is outside. Okay. And let's see, the probability of A is 2, 6. And then the probability of B is 1, 2, 3, 4, 6. And F, find the probability that the number rolled is not a square number. The number rolled is not a square number. So if the probability that the number is a square number is 2, 6, then the probability that it's not a square number would be 4, 6, right? 4, 6. And find the probability that the number rolled is both a square number and a factor of 6. Both a square number and a factor of 6. So that would be just 1, right? So that would be 1/6. Find the probability that the number rolled is either a square number or a factor of 6 or both. So that would be probability of A union B, right? So that would be everything except for the 5. So that would be 5/6. Verify that both probability of complement of A is equal to 1 minus uh, probability of A, and probability of A union B is equal to probability of A plus probability of B minus probability of A union B. So complement of A would be 4/6 is equal to 1 minus, and the probability of A is 2/6. So yeah, that works. What about this one? Probability of A union B, there are 1, 2, 3, 4, 5 elements there. 5/6 is equal to probability of A, which is 2/6, plus probability of B, which is 4/6. And then we subtract out the elements that are in both, which is 1/6. Okay. Number 2. The numbers 3, 4, 5, 6, 7, 8, 9, 10 are written on identical pieces of card and placed in a bag. A random experiment is a card selected at random from the bag. A be the element a prime number is chosen, and B be the event that an even number is chosen. Okay, so we're going to have A is a prime number is chosen, and B, and I think I'm going to redraw that so that the intersection is a little bigger. An even number is chosen. Okay, so list the elements of A. So let's see, A is prime number, so that would be 3, 5, 7, and that's it. And the elements of set B are even numbers, so that would be 4, 6, 8, 10. So in B we'll put 4, 6, 8, 10. And in A we'll have 3, 5, 7. Okay, and then show sets A and B on a Venn diagram. Okay, we've done that. Write down probability of A. Probability of A, well, let's figure out how much is in the middle. None, right? None of those elements are common. How many elements are outside? Well, let's see. What about 3, 4, 5, they're already there. 6, 7, they're already there. 8, 9, 10. Well, 9 is the only one that's not there, right? So we'll put 9 outside. And now we can do our calculations. So write down probability of A. Probability of A is there's 3 elements divided by all the elements. And all the elements are, it looks like there's about 4, 5, 6, 7, 8. There's 8 elements. So it would be 3/8, right? And the probability of event B happening would be 1, 2, 3, 4 divided by 8. Okay, and then find the probability that the number rolled is a composite, not a prime. Is composite, not a prime. So that would be probability of not a prime is equal to 1 minus the probability of being a prime. So that would be 1 minus 3/8. So that'd be equal to 5/8. Find the probability that the number rolled is odd. So that would be 1 minus probability of B, which is 4/8. That would be 4/8. Okay? And then find the probability that the number rolled is both even and prime. Even and prime. Well, there's nothing in there, so that would be 0. Find the probability that the number rolled is either even or prime or both. Even or prime or both. So that would be 3, 5, 7 or 4, 8, 6, 10 all together, so that would be 7/8. Verify that both the A complement is equal to 1 minus A and B complement is 1 minus B. So let's see, the probability of A happening is 3/8. Probability of A not happening is 5/8. So let's see if that works out. 5/8 is equal to 1 minus 3/8. Yeah, that worked out. And then probability of B complement is equal to 1 minus probability of B. B complement is 4/8 minus 1 minus equals 1 minus 4/8. Yeah, so that worked out too, right? Okay. Verify that probability of A union B is equal to probability of A plus probability of B minus probability of A union B. So that would be probability of A union B is 1, 2, 3, 4, 5. There's 7 elements. Okay, so 7/8 is equal to probability of A would be 3 out of 8. Probability of B would be 4 out of 8. And then we subtract out the intersection is just 0. So yeah, that works out. Find the probability that the number rolled is either odd or composite or both. So let's see. Odd would be these. Composite would be either odd or composite or both. So that's like everything, right? So that would be 1. The probability is 1. Okay, now we're going to verify this last one here. So the probability of not A union with not B. Now not A would be basically saying composite. Not B is basically saying odd. So basically we're saying the probability that we had in M. So that would be 1. Probability of not prime would be all the elements that are outside of prime, which are 5 elements. Probability of not B would be all the elements outside of B would be 4 elements. And then the intersection of both of those would be just 1 element, which is the 9. So that would be 1 also. So we verified that. Okay, now we move on to number 3. The elements 2, 3, 4, 5, 6, 7, 8, 9 are written on identical pieces of card placed in a bag. Random experiment is card is drawn from the bag at random. Okay, let event A is going to be odd number chosen. Element B is going to be a square number is chosen. List the elements of A. So that would be an odd chosen, which would be 3, 5, 7, 9. List the elements of B, which would be a square number chosen, which is 4 and 9. So B is 4 and 9, and A is 3, 5, 7, and 9. Look, 9's in both, so we want to put 9 in the middle. Okay. Show sets A and B on a Venn diagram. We did that. Write down the probability of A. Probability of A would be 1, 2, 3, 4 elements out of 8. So we'll put 4 out of 8. Write down the probability of B. That would be 2 out of 8. Find the probability that an odd square number is chosen. That's the intersection of both. So that would be 1 element. Would be the 9, right? Find the probability that either an odd number or a square number is chosen. That's 5 out of 8. And then verify that the probability of A union B is equal to probability of A plus the probability of B minus the probability of A intersect B. Probability of A union B is 5/8. Probability of A is 4/8. Probability of B is 2/8. Probability of A intersect B is 1/8. Right? Just the 9. So that works out, right? So yes, we verified it. Okay. A random experiment is toss 2 unbiased coins. List the set of 4 equally likely outcomes. So that would be heads, 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 tails, tails, heads, and tails, tails. Those would be 4 equally likely outcomes. Find the probability that 2 heads show. It's just 1 out of the 4, so that would be 1/4. Probability that 1 head shows, well, that would be these 2, so that would be 2 out of 4. Probability that no heads shows, that would be 1 out of 4 again. Okay. A random experiment is toss 3 unbiased coins. List the set of 8 equally likely outcomes. So that would be heads, heads, heads. It would be heads, tails, tails. It would be heads, heads, tails. It would be heads, tails, heads. Heads, sorry, I think that's it for the heads. Now we'll start with tails. So it would be tails, heads, heads. It would be tails, 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 heads, tails, and tails, tails, heads. So there's 8 possibilities, right? Find the probability of no heads. Well, no heads is there's only one, right? It would be that one. So we'll put 1 out of 8. Probability of one head. Okay, one head would be that one, and that one, and that one. So that would be 3 eighths. Probability of two heads. So that would be that one, and that one. So that would be 3/8. And the probability of 3 heads would be 1/8 also. Okay, 6. A random experiment is toss 4 unbiased coins. Okay, so now we're going to get more. So we got heads, 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 heads. We got heads, 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 tails. We got heads, heads, tails, heads. We got heads, tails, heads, heads. We got tails, heads, heads, heads. Now we have heads, heads, tails, tails. We got heads, tails, heads, tails. We have tails, heads, tails, heads. We have tails, tails, heads, heads. We have tails, heads, heads, tails. We have heads, tails, tails, heads. And then we have the case where we have one head. So that would be heads, tails, tails, tails. We have tails, heads, tails, tails. We have tails, tails, heads, tails. And we have tails, 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 heads. Okay, and then last of all, we have the case where we have four tails. Okay, so there's 16 possibilities here. Find the probability of no heads. So no heads would be just that one. So that would be 1 out of 16. Find the probability of 4 heads. 4 heads. So 4 heads would be that one. So that would also be 1 out of 16. Find the probability of 1 head. Now there's several. It would be 1, 2, 3, 4. So it would be 4 out of 16. Find the probability of 3 heads. 3 heads would be 1, 2, 3, 4. Also 4 out of 16. Use the answers A to D to deduce the probability of 2 heads. Well, the probability of 2 heads would be the probability of, it would be 1 minus all the other possibilities, which would be 0 heads, probability of 1 head, probability of 3 heads, and the probability of 4 heads. So if you add all those up, which are the ones you just had here, you would have 1 minus, 6 16. No, it would be 4 plus 4, 8, 9, 10. It would be 1 minus 10 16th. So that would be 6 16th. Okay, and let's check to see if that's right. We'll do it light green. So 2 heads, 2 heads, 2 heads, 2 heads, 2 heads, 2 heads, and that's 6. So that was right.